biomaterials, chemicals and electrochemical sensors, nanomaterials and energy systems. With an extensive research portfolio, he has contributed to the numerous high-impact international publications and actively collaborates on interdisciplinary research in material science and environmental applications. He has as a guest editor for reputed international journals. His contribution bridges fundamental science with practical applications and request our esteemed speaker, Professor Viet Lee, to address the gathering and show his valuable thoughts. Please, sir.
It's okay. So, is it work? No, not I. Ah. Steady. Hello. No. Yeah. Okay. Thank you very much, Professor Chairman, and good morning, everyone. My name is Viet Hai, Associate Professor Senior Lecturer from University of Science, Vietnam National University. Yeah. As you can see on the slide, I come from Ho Chi Minh City, the biggest city in Vietnam and the most important city in Vietnam. Some information about Vietnam you can find here on the slide. We are very little country compared to India. Yeah. And I would like to invite you to visit Vietnam on slide. There are many sightseeing, very beautiful places in Vietnam like Ha Long Bay, Nha Trang, Ke Bang National Park, or in Hoi An Ancient Town. Very famous for the tourists all over the world. And so on, some pictures from Da Nang City with Mỹ Sơn, or Bana Hill, or Phan Xipang Peak, or Mui Ne. Yeah. And I do hope that you, if you have an occasion, please visit to Vietnam and enjoy the beautiful place here. Yeah. So just come back to Ho Chi Minh City. There are some information about Ho Chi Minh City, about the population, the area, the GRDP, and the derivation, and so on. You can get some information. Yeah. Please come back to Vietnam National Ho Chi Minh City. In Vietnam, we have two national universities, one in Ho Chi Minh City and another in Hanoi City. And I come from VNU Ho Chi Minh. Yeah. You can see here we in Ho Chi Minh we have 6 members. In that we come from University of Science. You can see here. So you can set for the pointer equal or not? The pointer. Yeah. Yeah. Okay, sorry for pointer. No, it doesn't work. Yeah. And next, I would like to introduce some information about VNU-HCM. That's founded in 1942, a long time ago, and until now, we are the strong research and education center in Vietnam. Yeah, and we do all the mission for the do research and education also. Yeah. This is the faculty belong to VNU-HCM. The first one is we have the mathematics, computer science, the information technology, biotechnology, chemistry, electronics and geology, and also the material science and technology. We have also the division for the AI technology. For the graduate degree program, we have 9 programs, as you can see on the slide, in which we concentrate in the basic research and also for the application, like micro nano electronic engineering or nanomaterial. In our university, we have almost about 110 partners in all over the world. Yeah, and we have the cancer center and also IT, RD, and education center. We are ranking in QS World University around 800. Yeah. So come with the meeting today. We are looking for the cooperation for the joint research project and also for the international program exchange student and the workshop competition commit together, and also the scholarship for Master of PhD student. Yeah. Now I come to the main topic of my talk today. It's about the next generation electrochemical material and electrode assisted to for energy, water treatment, and chemical sensing. Yes. We are interested in the chemical sensor and biosensor for food and environmental monitoring. As you know, besides we are interested in the AA, the physical robotics, we also mention about the safety of food and safety of our health. In this context, our research focused on this topic 20 hours until now. And the second is for water treatment system based on new technology, especially for the water resource. And the last is for the material and the thought for the water treating to develop new energy, renewable energy. So I come for the first topic in that we development of electrochemical sensor for analytical system in methanol in alcoholic beverage and gasoline. This is a very hot topic in Vietnam and I think over the world, because you know in the beverage there are some during the enzymatic they form methanol in which a threat level in our food, so that we need a very sensitive and selective electrochemical system to detect that. And here I show you the system that we developed in our university, including a potential start and potential start and sprinting electrode that we made ourselves, Using this device, we can detect the methanol in bivouac and also in gasoline with a very low level at the ppm level. Yeah. And here I show you some information about the methanol sensor. The fact in the real in the market for development of the biosensor, normally they use the enzyme like that. But you know that like the weather in India are similar in Vietnam. The temperature is very high and the humidity high also. So the enzyme not stable in that condition. So the biosensor, the lifetime of the biosensor is about 6 months or lower than that. So our target is to change the enzyme by using the inorganic catalysis. And this case we develop some catalysis based on metal or metal oxide. And that is based on the substrate of conducting polymer. In this case we use polyaniline at a substrate that we give low cost electrochemical sensor, good sensitivity, selectivity, and it can restrict very, very stable in everyone. Yeah. Here is some information about the polyaniline and other additives like graphene and synthetic that we can use as conducting material to combine with polyaniline to enhance the electricity conductivity. And here are some steps and protocol to fabricate sensor electrode. And I list for several methods to characterize the morphology and also the chemical structure of the material. Here's some information about the result on the characterization of the material. I skip very fast like this. Yeah, using Raman, FTR. Yeah, and for the yeah. For the electrocatalytic activity, we use electrochemical method. In this, we use using cyclic photometry or chronometric method. Here we some result in HRTM or TEM or ADS. And you can see here the results based on the CV method. Yeah, this show the activity of the electrode material for methanol sensing. In this case, we can see that the nitrogen is very large and is sensitive to and selective to methanol, based on the catalyst developed from the nickel oxide, also hydroxide. And here I show you the calibration and some characteristics of the sensor based on the metal, nickel metal decorated on Pani system. Yeah. With low cost electrochemical sensor and good sensitivity, high selectivity, and high predictability with long-term stability. Next to another parameter related to the catalytic system that we have already developed. Yes. You can see here. You can see here the selectivity for methanol compared to acetone or EBR or ethanol in the aqueous solution. That means we can use this sensor to detect methanol in aqueous media very effective. And next, I would like to show you another material, another nanomaterial developed for detection of uric acid in human blood. That also published on the. Here we use a composite of copper and copper oxide in different oxidation state, and that so very sensitive for the detection of uric acid in real environmental. And for the next one, we use the catalyst developed on the printing electrode, and that had test event compared to develop on the FTO substrate that we can use directly for the monitoring of environmental or apply on the medical domain. And here in other approach, in this we use biomass. And here is from the silicon. I look at silicon very popular in here. So we use the silicon plant and trace it to get the carbon aerosol. In that substrate, we incorporate with nanoparticle of nickel, and then use this electrode we can detect glucose in blood sample. It's very sensitive and bio friendly. And for the filter, the current we try to develop the electrode on paper or on the PET substrate, and that we can customize the size and the shape of the electrode sensor, and also we developed the mini potential start that we can use directly to the commercial. Yeah. And for the next topic, I would like to introduce with you about the water treatment system based on new technology. In this case, we use capacity deionization CDI technology. This is the mechanism of the system based on CDI technology, in which the main component of this system is the porous material that we can fabricate using biomass like silicon or like coconut shell or many kind of biomass product that you can find in agriculture. And in this report, I will show you two kind of porous material. The first one is related to activated carbon electrode, and the second one related to carbon aerosol. That we have built a protocol to synthesize the material at scale of a pilot and could be transferred to the end researcher. Here is I show you the prototype to synthesis of carbon activated carbon from coconut shell, and we combine this porous material with our CNT or graphene to make quantity porous material that can use as the porous material to fabricate of the CDI electrode. Yeah. And the second one I show you the related to the fabrication of carbon aerosol using the coconut fiber. Yeah. It's a two-step to form first to synthesis of carbon cellulose gel, and then we switch the head to get the carbon aerosol with a very high porous characteristic. Yeah. And using the starting material from the porous carbon connective CNT, we fabricate the electrode with any size that we wish. And using the, and using this electrode, we can fabricate the module with many electrodes, as you can see on the slide. This module contains 350 electrodes connect together, and we can connect 3 modules together to get to enhance the capacity of the system. And using this module, we build a CDI system. In that this case, we can apply to use for water treatment. Yeah. This system can be reach capacity of 5 to 7 cubic meter per day, and it's run with a very low energy consumption, minus than 0.1 watts by liter. And this system can be applied for many purposes, mainly for water desalination, for industrial, or also for agriculture, very effectively. Yeah. And the last topic, I would like to introduce you about the electrode for water splitting. In that case, we synthesize the photocatalytic material at the form of the past. That part we can use to fabricate electrode by using the screen printing method. Yeah. And these materials are very effectively for the solar light, yeah, with a very high efficiency. And for the future, then we going to fabricate all the composite material based on this method, and the final product we obtain at the form of the past material that can very easy to use for fabricate of the electrode for inhibitor. And related to this topic, we have a core project with Dr. Hamra is here, and here we are the leader project in Vietnam. Yeah. So Vietnam and India have a strong cooperation has been established in 2016. So that we do hope that we can have a very strong cooperation also in science research and education. And thank you very much for your attention. Yeah. Thank you.
Thank you so much. Thank you so much, Professor Lee, for your insightful session. The floor is open for the question. If anyone is having question, we will take 2 questions.
I have been working on silica aerogel as well as graphene aerogel. Good to see the aerogel. My question is, right now many people are trying to mimic the structure of aerogel using the additive manufacturing. So what is your take on it? So they are getting rid of the complete chemistry and they got a really good applications in nanometers and
Thank you very much for your very interesting question. You mean the combination of the carbon or other material, other porous material to apply in various domain for publication or for fabrication to some product to the industrial, right? In this case, you can see on our research, we developed many kind of porous material like activated carbon or carbon aerosol. But normally with the carbon aerosol, we have to keep its structure like that we can remain its porous characteristic. However, for that topic, if we fabricate carbon aerosol with the size like that, we can apply only on the lab for polymer or for something like fiber or something like that. But for the application in industrial, we have tried to do another way. I mean, yeah, you can combine it with other material like silicon or for fabricate of lithium battery, electrode for lithium battery in state of chain with graphite, traditional graphite with your nanomaterial, the silicon from right hertz, for example, and combine with the conductivity of carbon aerosol instead of carbon black or the other carbon material. Yeah. Thank you.
I have one question.
Yes, please, sir.
It's okay that being very effectively used for the saline water.
Yeah, for salinity. Yeah.
But whether this can be really used for reducing the TDS of BOD or COD of any
Yeah. Thank you very much for your interesting question. Actually, the CDI system can be used for desalination, as you already mentioned. Yes. However, the mechanism of the system is work based on the absorb the electrical absorb of ion into the surface of electrode, so that we can apply not only for salt desalination but also for all the metal like copper or ferro or any. Yes, and it worked very well. And I think you can use this system for treat the water like that. You can sell the water result. It's very effective because it's work. The potential apply is below 1.2 volt. I mean below the water electrolysis of water. Yes, so that is saving that. Yeah, thank you.
Thank you so much, Professor Lee. Thank you, sir.
Okay, thank you very
will-
much for your attention.
We'll proceed for our next speaker. It is my pleasure to introduce our next speaker, Dr. Hemraj Yadav. Dr. Yadav is Ramanujan Fellow and several patents to his credit. With global academic experience in South Korea and